We are looking at arithmetic operations of matrices. So let's look at addition of matrices. Two matrices can be added only if they have the same size. In other words, the same dimension. Once the two matrices have the same size or the same dimension, then these two, and anytime we are adding two matrices, we add the elements in the corresponding positions in each matrix. So let's take these two matrices, for instance, let's add them. A plus E. Then we add B to F. We add C to G, D to H, in that order. So same dimension, the first is 2 by 2, the second is 2 by 2. Then add corresponding values. A corresponds to E, B corresponds to F, C corresponds to G, D corresponds to H, in that order. So this will be our results. When you take the second example, you have A, which is at the position of first example. A, first row, first column will be added to B, which is at the position of first row, first column. A in the first row, second column will be added to the B, which is first row, second column, in that order. So this will be added to this will be added to this. Then this becomes your results. So this is how addition of matrices is done. So let's take some few examples. Let's have matrix A, B, and C. We have to find A plus B, B plus A, and A plus brackets open B plus C. Likewise, A plus B into bracket plus C. Then after that, we look at what the relationship between A and B, and then also the relationship between C, the results of C, and then that's of D. So let's go on. So we have matrix A plus B. Our matrix A is minus 5, 3, 2, minus 1. Our matrix B is 4, minus 3, 7, minus 5. So remember, the condition is that both matrices must be of the same dimension. So the first one, 2 by 2, second, 2 by 2 matrix. Then we add corresponding values. So know that minus 5 corresponds to 4. So minus 5 plus 4. 3 corresponds to minus 3 in the second matrix. So with this 3, that's it. Minus this 3, that's it. 2 corresponds to 7. So you add 2 plus 7. Minus 1 plus minus 5. They correspond. So our results will be minus 1, 0, 9, minus 6. Then let's have the matrix B plus A. So 4 will be added to minus 5. Minus 3 plus 3, 7 plus 2, minus 5 plus minus 1. Let's see the results. So we are going to have minus 1, 0, 9, minus 6. All right. Then let's look at the C. Our C question, remember the C, we are supposed to find A plus brackets open B plus C brackets close. So we have to do bracket first. That's we have to do B plus C first. So remember, they must be of the same dimension. So first matrix 2 by 2, second matrix 2 by 2. Then we add corresponding value. 4 correspond to minus 1. So 4 minus 1. Minus 3 correspond to 3. So minus 3 plus 3. 7 correspond to 5. So 7 plus 5. Minus 5 correspond to 4. So minus 5 plus 4. And this will give us these results. 3, 0, 12, minus 1. Now that we know B plus C, then what we do? We come and add matrix A to these results. So our matrix A, which is minus 5, 3, 2, minus 1, will be added to the results of B plus C. So minus 5 corresponds to 3, so minus 5 plus 3, 3 plus 0, 2 plus 12, minus 1 plus minus 1. So let's see the results. This will give us minus 2, 3, 4, and minus 2. Again, we have to add A plus B, all into brackets, plus C. So you add, remember we've already added A and B, and that's the results here. That's the results. So let's pick the results here, and that's it. Minus 1, 0, 9, minus 6, plus our C, our matrix C. And you know this is our matrix C. So we are coming to add it to the results of A plus B. So same dimension. Then we add corresponding value. So minus 1 will be added to minus 1. 9 plus 5. 0 plus 3. Minus 6 plus 4. Then you have a result of minus 2, 3, 14, and minus 2. Now let's look at the relationship. You remember we were asked to find what is the relationship between your answers in A and B, and what is the relationship between your answers in C and D. So we found that matrix A plus B is the same as matrix B plus A. As a result of that, we can conclude by saying matrix addition is commutative. Matrix addition is commutative. There's the result we had for A plus B. Minus 1, 0, 9, minus 6. And then the same results we had for B plus A. Matrix B plus A. Minus 1, 0, 9, minus 6. Then F. We had to find the relationship between this and this. Then what did we realize? We realized that this summation of this equal to the summation of this. Therefore, matrix addition is associativity. So matrix addition defines associativity. Let's look at subtraction of matrices. Subtraction of matrices. The same condition hold over here. The condition that holds under additions holds here. And thus, the two matrices need to be of the same size or the same dimension. Then again, to subtract the two matrices, you need to subtract the elements in the corresponding positions in each matrix, the same as the addition 1. The same thing. The same thing. So let's have, if we have matrix A, B, and C like this, we have to evaluate the following. So we should find matrix A minus B, then matrix B minus A. Then after that, we look at the relationship between the results of A and B. That's what is the relationship between your answers in A and B. So let's go. We have matrix A minus B. So this is our matrix A. This is our matrix B. Remember, we subtract corresponding value. Minus 5 corresponds to 4. So minus 5 minus 4. 3 corresponds to minus 3. So we are going to have 3 minus. Remember, this is the minus. And the 3 itself is also minus. So 3 minus minus 3. 2 corresponds to 7, so 2 minus 7, that's it. Minus 1 minus 5. So what do we get? Minus 5 minus 4 give us minus 9. 3 minus minus, so negative, negative, plus, will give us 6. 2 minus 7 minus 5. Minus 1 minus minus 5 give us 4. Know that this minus minus positive. Let's look at scalar multiplication of matrices. Now all the entries of matrix can be multiplied by a common factor called a scalar factor, K, in a process called scalar multiplication. To obtain a scalar product, that's if we have a matrix A like this, and we want to multiply by K, then our result will be like this. K times matrix A. So K will multiply A, K will multiply B, K will multiply C, K will multiply D. In that order. So if we have K, which is minus 1, and then you want to multiply, that's minus 1 by matrix A, then there's the result. We have minus A, minus B, minus C, minus D. So let's take this example. We have matrix P, this, and Q, this. We have to find minus 5 times P. So you are going to multiply every element here by minus 5. Then Q, 1/3 of Q. So you are going to multiply this matrix by each element by 1/3. So let's see the results. So you are going to have minus 5 times P. So this side will be so minus 5 times 4. In that order, minus 5 times 1. Minus 5 times 2. Minus 5 times 3. So our results, minus 20, positive 5, minus 10, because minus 5 times 2, minus 10. Minus 5 times 3, minus 15. Then we do this one to multiply our scalar multiple is 1/3. So we multiply each element by 1/3. So 1/3 of 12, 1/3 of 13, 1/3 of minus 3, 1/3 of minus 9. Then our results will be like this. 4, then 4.3. You can leave it in the fraction form, improper fraction form. Minus 1, minus 3. And that's what that. Now, let's look at multiplication of matrices. This is different from scalar multiple of matrices. Over here, we multiply a matrix by another matrix. We multiply a matrix by another matrix. So there are conditions. Matrix multiplication, unlike multiplying individual numbers, involve a specific process for combining elements from two matrices to create a new matrix. The two matrices have compatible dimension for matrices multiplication to be possible. So the first point, what it's saying is that before we be able to multiply two matrices, then there must be compatibility. So let's look at this compatibility condition. So the number of columns in the first matrix, the number of columns in the first matrix must be equal to the number of rows in the second matrix. The number of columns is n. This must be equal to the number of rows in the second matrix. So the number of rows over here. So if here is 3, this side must also be 3. If here is 4, this side must also be 4. Before the two matrices can be multiplied. The resulting product matrix will have dimension m by q. M by q. So when you multiply matrix A by matrix B on this dimension, then our results, the dimension will be, it will take the first row, the number of rows of the first matrix, and then take the number of columns of the second matrix. So our results will be m by q. So let's put all these things into a simple term. Let's put into a simple term. So under multiplication of matrices, this need to be remembered every day. So row times column equal to 1 entry. So we have matrix A, matrix B, we want to multiply. So know the condition. The number of columns in the first matrix must be equal to the number of rows in the second matrix. So let's look at the condition for multiplication. This rule. We multiply row by column to get 1 entry. So if we are going to multiply this matrix by this, then row times a column will give us a single entry like this. So row by this column will give us this entry. Row by this column will give us this entry. Then row by this column will give us the last entry. So let's see. You have A times E. That's it. B times G. Then we add it to it. Then we come again A times F. B times H. Get this. So we are done with this row in the first matrix. So we are now coming to pick the second row and then multiply by each column in the second matrix. So that's what the condition says. So we have C times G C times E, D times G, C times F, CF, D times H. So that is how the multiplication is done. So let's take some practical ones. Given that matrix A is this and matrix B is this, we are to evaluate the following: matrix A times B and B times A. Then we'll state the relationship between the answers in A and B. So let's take practical. So we are going to have 4 times minus 2. That's it. That's minus 2. That's 4 times that's minus 2. That's it. Then minus 2 times minus 2. Minus 2 times, know that is row times column. So minus 2 times minus 2. Minus 2 times minus 2. And 4 times 3. 4 times 3. Minus 2 times minus 7. Give us this. So we are done with this. So we are now coming to pick the second row and multiply by each column of the second matrix. So 1 times minus 2. That's it. 3 times minus 2 over here. Then again, the row times the second column in the second matrix. 1 times 3 to get each entry. So 4 times minus 2 plus minus 2 times minus 2, which gives us minus 4. The same thing here. Let's times this. Simplification of this will give us 6, 26. When you simplify here, 1 times minus 2 plus 3 times minus 2 minus 8. 1 times 3 plus 3 times minus 7 minus 18. The same thing. Row times column. Row times column. So this row times this column give us this entry. The same row times this column. So that's minus 2 times 4. 3 times 1. Minus 2 times minus 2. 3 times 3. So you are done with this row. Then you come and pick the second row. Minus 2 times 4. Minus 7 times 1. So you add. Minus 2 times minus 2. Minus 3. Minus 7 times 3. Then you do your simplification. Over here, you can just put it on your calculator. Minus 2 times 4 plus 3 times 1. This will result to minus 5, 13, minus 15, minus 17. Now, when we compare our answer in A to B, we realize that matrix A, B is not equal to BA. Therefore, we conclude that matrix multiplication is not commutative. Matrix multiplication is not commutative. Alright, so these are trial questions for you.